Kenneth Music number one.
It's Joel Amadi. It's yeah. We are serving a living God. Oh, yeah. That is why.
Ladies and gentlemen, I want to believe you are doing great. You are doing fine. There's another time to learn. Now we'll continue from our next topic, which is magnetism and electromagnetism. Magnetism and electromagnetism. This topic is for all the SS2 students and SS3. This physics. Okay, now let's look at the introduction. Now this chapter is somewhat of a departure from the coverage of DC circuits in the previous test we have done, because two totally different concepts are introduced: magnetism and electromagnetism. Now the concept of electromagnetic induction is important in electrical component called an inductor or coil. So please take note of that. And there are the operation of any type of device such as relay, the signal, the speaker is based partially on magnetic principle. So it's going to be it's going to do us good if we look at it in a good way. And we can also learn that the electromagnetic relay can be used in burglary alarm system, and you will develop a procedure to check out the basic alarm system which normally work. So now let's try to look at the next one. Now magnetic field. Now we have some field in physics. We have what is called electric field, we have gravitational field, we have magnetic field. Now what you are experiencing or the influence that is happening on the field depend on the type of name you will give it. So when you have a field and what you can feel on the field is electrical charge, is called electrical field. So when we are talking about magnetic field, it's a field that is surrounding by magnetic flux or something that have to do with magnetism stuff. Okay, now we are told that a permanent magnet has a magnetic field surrounding it. A permanent magnet has a magnetic field surrounding it. Now magnetic field consists of line of forces that radiate from the North Pole to the South Pole and back to the North Pole to the South Pole magnetic material. So what are they trying to tell us? That now we are talking about a magnetic field. You have some line that move from the north to the South Pole, and also back from the North Pole to the magnetic material. Okay, a permanent magnet such as bar magnet shown below has a magnetic field surrounding it. You can visualize the magnetic field as it consists of line of forces or flux line that radiate from the North Pole to the South Pole and back to the North Pole to the magnetic materials. Okay, to the magnetic material. So you can see below. You can see the diagram, and that is magnetic line of forces around a bar magnet. You can see the north in the form like a pink. You can see the south in form like a blue. Then the line, that is what we call line of forces, is moving from the north to the south, and also from south it now come back again. That is what we call magnetic line of bar magnet. That is a line representing only a few of many magnetic line of force in a magnetic field. Okay, now when we are talking about magnetism, we can't just put aside the law, the state that attraction and repulsion of magnetic pole, attraction and repulsion of magnetic pole. Now what happened when you have what? North and south, and south and south, bring together. Okay, now when we talk about what unlike pole of two permanent magnets are placed close together, an attractive force is produced by the magnetic field as indicated in figure what? In figure A. Now we are told that when two like poles are brought close together, they repel each other, and also when two unlike poles are brought together, they attract each other. Now, what's the meaning of like pole? Like pole means north, south, south. If you bring south, south together, there is a what? There is a force that will repel. That is not going to what? Bring them together. It's going to repel them. Why? When you bring what? Unlike pole, when you bring north and south together, there is this force of attraction that occur between them, and that is what we call what? Attraction and repulsion of magnetic pole. So you can see the diagram for what? You can see the south and the north. You can see that there is what? Attraction. That is when the line is joined together. You see when you have what? Like pole, that is south and south, they repel what? They repel each other. Okay, now let's talk about what? The magnetic flux. Magnetic flux. Now the group of force line going from the north pole to the south pole of a magnet is called the magnetic flux. So it's those lines that is going from north to south are called magnetic flux, and they are defined by the Greek letter bar, that is the number of line of force in a magnetic field. Determine the value of flux. Determine the number of force, that is the number of line of force in the magnetic field. Determine the value of the flux. So the more line of force, the greater the flux, and the stronger the magnetic field is. You can see that one affects the other. So you are told that when the line of force is what? Is much, so you are going to have what? The greater flux, and due to greater force flux, we are going to have what? A strong magnetic field. Now let's look at what? Magnetic field density. Magnetic field density is B. Now magnetic field density is the amount of flux per unit area perpendicular to the what? To the magnetic field, and it's given as B is equal to what? That is the flux over what? Over area, where that theta is the flux and A is the cross-sectional area in square meter, 1 meter square of the magnetic field. Okay, now let's just look at some example. Now we are to the example 1. Find the flux density in a magnetic field which the flux is 0.1 meter square is 800 microweber. So what do? We have your asked to find the magnetic flux, which is your B is equal to the A. Now the flux is given to be 800 microweber, and the area is given to what? Is 0.1 meter square. So we just divide that, then your final answer is equal to what? 8,000 microtesla or Weber. So that's the unit for what? For magnetic flux density. Now let's look at example 2. We are told that if the flux density in a certain magnetic area is 2.3 T and the area of the material is 0.38 in square, what is the flux through the material? Okay, just the first thing you need to do is need to convert to square meter. We have is what? 0.38 in square. So what do? You convert it to what? To meter, and I thought that 39.37 in is the same thing as 1 meter. So therefore, your area is going to be what? 0.38 in square meter is equal to 39.31 in square. So you just square it, then you are going to have 24 by times 10 raised to the power minus 6 meter square. Okay, now so we have that. Okay, so that's our final That's it. So now to now find the flux through the materials, it's going to be that is flux is going to be A. You have been able to get your what your B is given from the question, which is the magnetic materials, the flux density to 2.3, and then multiplied by your cross-sectional area. So you have 564 microweber. Okay, now we lead us to another topic here, subtopic rather, how materials become magnetized. How some materials can be what magnetized. Now we are told that ferromagnet materials such as iron, nickel, cobalt become magnetized when placed in magnetic field of a magnet. Now you see some electrician, they put a some speaker down that is having a magnet only, so they started putting their screwdriver on top. What they are trying to do at that moment is that they want the iron part of the screwdriver to become what to have that property of magnet, so that they can use it to what take up their screw and all this. So that is what they are trying, that if you bring them in a magnetic in a field, so you are going to have what is called magnetized. So they become magnetized. So in this case, the object become magnetized. So that this is actually become a magnet itself under the influence of permanent magnetic field and become attracted to the magnet also. Okay, now when the materials is placed in the magnetic field, the domain align themselves object and not those things. Okay, so that is that. We have some of applications of this now. The permanent magnet have numerous applications. The normally closed NC magnet switch is presented here as an illustration. Okay, so illustration. So switches of this type are commonly used in perimeter of alarm system to detect entry into a building through the windows or doors. So now we can use it as a protective device. And also, so the next time we meet, we continue from this magnetism. We talk about how you can dismagnetize by heating method, by hammering method. Then we now look at what electromagnetic induction, how you pass a current through a wire and you turn it to have a magnetic property. So now, I want to believe you have understanding of today's topic, magnetism and electromagnetic induction. So the next time we are going to give you some calculation to do on this topic, so that we can have more understanding of it. Thank you. God bless you. Please keep safe.